Now discuss about the conservative and non-conservative forces. Conservative and non-conservative forces. So first we discuss about the conservative forces. Those forces in which work done by this force or against this force depends only initial and final positions, does not depend the path followed, known as conservative forces. Forces are said to be conservative forces in which work done by this force or against this force depends only initial and final positions, does not depend the path followed, and work done in a round trip is equals to 0, known as conservative forces. Clear? So what are the properties of conservative forces? First property, they depends only initial and final positions. They depend only initial and final positions. Second property, they does not depend the path followed. They totally independent of the path followed. It does not depend the path followed. And third property, work done in a round trip is always 0. So these are the three properties of conservative forces. Clear? Examples: gravity is a conservative force. Gravity is a conservative force. The simplest example. Okay? Now discuss about the non-conservative forces. Non-conservative forces. Non-conservative forces. Forces are said to be non-conservative forces in which work done by this force depends on path followed and work done in a round trip not be 0, is not equal to 0. That depends on the actual path followed and work done in a round trip is exist, it is not equal to 0. Examples: frictional force is a non-conservative force, viscous force non-conservative force, air resistance non-conservative forces. They depend the path followed and work done is not equal to 0 in a round trip, known as non-conservative forces. Clear? Now we want to prove gravity is a conservative forces. We want to prove gravity is a conservative forces. Conservative force. It is possible only if you prove that they independent of the path followed, they depends on the initial final positions, and work done in a round trip is equals to 0. Okay? Now, the first case. In the body of mass m, lying on the surface, that is at point A, B is the point, and you want to shift this body straight upward up to point B, and the distance between them is h. In the case of lift, just like a lift. So body of mass m lying on the surface, and we want to shift at point B against the gravity vertically upwards up to a height h. Okay, so work done will be, as you know, that work done against the gravity mgh. So WA to B equals to mgh. Okay, in the first case. Second case, now we change the path. It's a stair-like structure. Stair-like structure. Position same. Again, h is the vertical separation, and here h equals to h1 plus h2 plus h3. Okay. Now work done. W equals to w1 plus w2 plus w3. So what is w1? mgh1, w2 mgh2, w3 mgh3. Okay, w1 w2 w3, mgh1 mgh2 mgh3. Putting these values in equation second. So w equals to mg common h1 plus h2 plus h3. Okay, and from equation first, h1 plus h2 plus h3 equals to h. So it is again mgh. Although we change the path, but again answer is same, that is mgh. It means they do not depend the path forward. Now third case. It is h. Inclined surface. Third case is the inclined plane. Angle theta. That is A and it is B. Again, separation between A and B is h. Vertical separation remains same. Now is the body. Weight acting downwards. In the normal reaction, and this angle is also close to theta. Now here, weight resolving into two components. mg cos theta and mg sin theta. And suppose this distance is s. The length of the inclined plane is s. Vertical separation is h. Now w equals to mg sin theta into s. Work done to move body from A to B, it will be equals to mg sin theta into s. Change sin theta. Mg. What is the value of sin theta from this diagram? hys into s. So it is again mgh. So there are the three observations, and it is clear from all these three observations, work done against the gravity depends only initial and final positions, does not depend the path followed. Here The lift is just like a lift, and here is the straight structure and is inclined plane. But in all the cases, it is clear the work done against the gravity depends only initial and final positions, does not depend the path followed. Now third property, W AB equals to W A to B plus W B to A. W AB equals to MGH and is minus MGH. MGH minus MGH. So W AB equals to 0 is the third property. Work done in a round trip is equals to 0. That's why gravity is a conservative force. Clear? So all three properties clear. First, depends only initial and final positions, does not depend the path followed, and the third property, work done in a round trip is equals to 0. Okay? Now we discuss one numerical, very important numerical, in which we can prove that gravity is a conservative force and frictional force is non-conservative force. So this is a very good numerical. Now, listen statement. A body of mass m equals to 0.3 kg is taken up an inclined plane of length 10 meter and height 5 meter and then allowed to slide down to the bottom again. The coefficient of friction between the body and the plane is 0.15. What is the first case? Work done by the gravitational force over the round trip. Second case, work done by the applied force on the upward journey. Third case, work done by the frictional force over the round trip. And fourth case, kinetic energy of the body at the end of the trip is the question. Okay? Listen again. According to the question, is diagram. It is h and h is given. It is 5 meter. S, that is 10 meter. A body of mass 0.3 kg. 0.3 kg is taken up an inclined plane of length 10 meter and height 5 meter and then allowed to slide down again to the bottom. The coefficient of friction is given. It is 0.15. Okay? And then calculate the work done. We discuss one by one. The first case, work done by the gravitational force over the round trip. And as we know that gravity is a conservative force. And we also know that work done in a round trip for gravity is equals to 0. Is the third property of the conservative forces. That's why work done in first case for round trip is equals to 0 according to the properties of conservative forces. That's why W equals to 0. Is it clear? second case. Work done by the applied force on the upward journey. Okay, so the body line way downward, normal reaction, it is theta, it is mg cos theta, and here it is mg sin theta. Body moves upward, that's why friction will be in opposite direction. As you know that from the chapter friction, W equals mg sin theta plus mu mg cos theta into s. Mg common, sin theta plus mu cos theta into s. The expression of the work done on a rough inclined plane upwards from frictional force, from the friction chapter. Now putting the values. If h is 5, s is 10, then sin theta will be h by s, so 5 by 10 so it equals to 1 by 2, or theta equals to 30 degree. It means theta will be 30 degree. So W equals, mass is given 0.3, small g 9.8, sin 30 1 by 2, mu 0.15, sin 30 cos 30 root 3 by 2, s is 10. Okay, so W equals to 9.8 into 3 by 2 common 1 plus 0.15 into root 3, and when we solve it, the answer will be 18.5 joule. It's 18.5 joule. Now, third case. Work done by the frictional force over the round trip. And as you know that friction is non-conservative force. Work done for round trip is not equal to 0. That's why in the case of second, now third case, W equals. And we also know that work done by the frictional force always negative. It's always negative. That's why it is minus 2s cos theta into mu mt. Okay, minus 2s cos theta into mu mt, minus 2 s. Why it is twice? Because W1 plus W2. Friction always opposite to the applied force. If body moves upward, the direction of frictional force will be downward. And when the body moves downward, the direction of the frictional force will be upwards. That's why it is twice. So twice of mg cos theta, twice of mu mg cos theta into s is the work done by the frictional force. S 10 cos 30 3 by 2 mu 0.15 0.3 into 9.8. So after solving, it will be minus 7.60. So in the third case, I proved that the frictional force is non-conservative force. Work done adjust कर रहा है. That's why. And the fourth case, kinetic energy of the body at the end of the trip. Fourth case, kinetic energy. Okay? Kinetic energy means work done only. Work done is also type of energy. The total work done is equals to kinetic energy. Means W1 plus W2 plus W3. ये तो वर्क एनर्जी प्रिंसिपल अभी आएगा. Work done equals to change in kinetic energy. So kinetic energy is equals to W1 is 0, W2 is 18.5, W3 7.6. Clear? और आंसर मिलेगा आपको 10.90. It's 10.90. This is a very good question in which we prove that gravity is a conservative force and friction is a non-conservative force. Because in first case, work done by the gravity over the round trip is equals to 0. And the third case, work done by the frictional force over the round trip, so it is minus 2 mu mgs cos theta. Twice, because one is upward and the second one is downward. It's a non-conservative force. It depends on the path. It depends on the path. So it is minus 2s cos theta mu mg. And the last, kinetic energy. And from the work energy theorem, जो भी आएगा, work done is equals to change in kinetic energy. That's why it is 10.90. Clear? So gravity is a conservative force, and we discuss about the conservative as well as non-conservative forces, and then our numerical, good numerical.